All right, so we are going to finish out the last page of our notes from 4.3. So you'll have to go back a little bit. And what we did was I wanted to cover all factoring so that we could just keep factoring, keep factoring, keep factoring. And then we're just going to add this tiny part to the end of factoring that has to do with equations, this equals 0 thing that we see right there, okay? So under 4.3, we're going to go to the last page. All right, and this is the top of the last page. These are just two more factoring problems, so we're going to skip those just because we've already done factoring. You do GCF for both, then you would factor depending on how many terms you have. So we're going to skip that, and we're going to go on straight into the solving. All right, and when it comes to solving, okay, if you notice you have a trinomial, but instead of just the trinomial, it's set up as an equation. So it actually equals something. And in this case, it equals 0. And you always want it to say equals 0, equals 0, equals 0. Okay? So that is key. That's exactly what we want. We want equals 0. Okay? So it's exactly the way we want to set it up. So then we just factor this. We go off to the side and we say, okay, since this is advanced because that 2, what numbers multiply to negative 42x squared and add to negative 1x? Remember, multiply the last times the first. And those two numbers are negative 7x and positive 6x. So remember, these two terms help us take this trinomial and make it, here, let me write it here instead. We're going to take this trinomial and we can now write it in 4 terms. So negative 7x plus 6x and then minus 21. All right, so these two numbers that we found help us pull apart the trinomial into 4 terms for our box. All right, I just wanted to make sure you could see it. So now we go to our box. This is the longest part. It's just more factoring. So we go to our box, 2x squared minus 7x plus a 6x minus a 21. So the GCFs are an x, a 3, a 2x, and a negative 7, because they're both negative. So I just want to multiply back in to make sure it all matches. So the binomials are x plus 3 or 2x minus 7. Okay? That's the longest part. The part that we're adding on to this is that now this times this equals 0. Okay, so it equals 0. And the 0 product property, it's a property that you did back like in Algebra 1, maybe even in middle school, says that anything times 0 will give you 0. So if either one of these is a 0, then it will equal 0. So in order to solve this, you just separate them, and each factor, x plus 3 is one factor, 2x minus 7 is the other factor, each factor equals 0. And then it just becomes a pretty basic 2-step equation, or 1-step. Okay? So each one equals 0, and then you just solve it. Subtract 3 from both sides. You get x equals 0 minus 3 is negative 3. Or, this is 2 steps. You're going to add 7 to both sides. 2x equals a 7. Divide both sides by 2, and you get 7 halves. Or if you say 3.5, you're fine. Means the same thing. Okay? So solving really just means that after you factor, each factor equals 0, and it's just two short equations to get the x equals something. So if you were to put either one back into this original equation, they actually would come out to 0. Everything would cancel out, and it would be a 0, like in your calculator if you were to plug it in. Okay? So let's do it a few more times. The longest part of this is the factoring part. That's why we're just doing factoring, 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 okay? Oh, wrong thing. All right, so, let's look at this next one. If you notice, this next one doesn't equal 0, but we need it to. We need an equals 0. That's what we want. We want an equals 0. Okay, so in order to say equals 0, we actually have to move these two terms over here. So we want to subtract the 6r so that it'll cancel. And you want to subtract it under the r because they're like terms. And you want to add the 12 so that they'll cancel. And you add it to your constant because they're the like terms, okay? So you always want equals 0. See, it says original equation into standard form. That would mean that it equals 0. Nothing is on the right, okay? So when you do that, you get a new trinomial, 4r squared minus 24r plus 36, okay? Now, we can factor, all right? And whenever we factor, the first thing we always looked for was the GCF. So, all of those divide by a 4. So we want to divide the 4 out of each of these. And if you divide the 4 out of each of those, that also means, since we have an equation, you can divide the 4 out of that as well. Okay, so divide each side by a 4. Okay, so if you divide each of those by 4, that's like factoring out the GCF, but you can drop it because you did it on the right side as well. So you get 0 over here. 4r squared divided by 4 is r squared minus 6r plus 9. Okay? Then we want to factor. Now this isn't easy factoring because it's basic, there's no number. Since we got rid of the 4, it made it basic. That's why you always want to factor first. Because it could, it could help you go from an advanced, which takes longer and it's harder, down to a basic, which is much faster. So, what multiplies to 9 and adds to negative 6? Okay, well that's a negative 3 and a negative 3. So these are the factors, x minus 3 and x minus 3. Okay, well since they repeat each other, that really just means that you've got 2 of them, so you get the same answer. When you set either one of them equal to 0, it's just x minus 3 equals 0 because it's the same thing. So when you add your 3 over, you get x equals 0 plus 3, which is 3, or r equals, sorry, let me put r's there. R equals 0 plus 3. And what I do is I call this a double root. Now we're going to talk about roots before we finish our unit. Okay, this is a double root because this 3 stands for both answers. Okay, there's 2 factors, so technically there should be 2 answers, but since it's the same number, that 3 stands for both answers that we would be looking for. Okay? Alright, so we'll do a couple of the practice problems, and then we will be finishing up, okay?